Hello friends, welcome to Engineering Funda family. In this video, I will explain unit step response of first order system. So you can observe here we have first order system and we have negative feedback, and that is unity negative feedback, right? Here with first order system, we have one pole. So you can observe with system in denominator we have as term, means here we have one pole. We are dealt with to identify unit step response, means input signal will be unit step input. So here R of S, that is input signal, for unit step input R of S will be 1 by S. Here our agenda is to identify response. Response means output. So we can identify output using transfer function. Transfer function is output C of S divided by input R of S. Here we have unity negative feedback. So transfer function, that is GS is 1 by ST divided by 1 plus GS HS. Here HS is 1 for unity feedback. Here if you take LCM of ST, then in numerator we will be having 1 and in denominator we will be having 1 plus ST. And this ST, that is getting cancelled from numerator and denominator. We need to identify output C of S. Here input R of S, that is 1 by S. So what is output C of S? C of S, that is R of S into transfer function. R of S is 1 by S and transfer function is 1 by 1 plus ST. So now we have output in Laplace domain. To get output in time domain, we need to apply inverse Laplace. But in multiplication, we cannot apply inverse Laplace. So to make it in additive form, we need to apply partial fraction expansion. Here in partial fraction expansion, this term, that is 1 by S into 1 divided by 1 plus ST. In additive form, it will be here A divided by S plus B divided by 1 plus ST, right? And if you further simplify this, then here in numerator we will be having 1, and after cross multiplication this is getting cancelled. With A we will be having 1 plus ST, and with B we will be having S. Now we need to identify constant A and B. To identify constant A and B, we need to assume value of S. If you assume S is equals to 0, then here if S is 0, then A will be 1, right? And if you assume S is equals to minus 1 by T, then 1 minus 1 will be 0. So here we will be having value of B, that will be minus T over this side, right? So that is how we can identify A and B. Now see C of S, that we can have in form of additive term. So C of S, that is A divided by S, where A is 1, so 1 by S, plus B divided by 1 by ST, B is minus T, so I can say minus T divided by 1 plus ST, right? Now we have this C of S and we need to simplify this further. So C of S, that is 1 by S, and if you take T common from numerator and denominator, then 1 divided by S plus 1 by T, that we will be having. And now we can apply inverse Laplace to this to get output in terms of time domain. So output C of T, see for 1 by S, we will be having U of T, and for 1 divided by S plus 1 by T, we will be having e to the power minus T by capital T into U of T. So if you take U of T common, then we will be having 1 minus e to the power minus t by capital T into u of t. So that is what our output in time domain. Now let me explain this output graphically. So here, see, we have unit step input, that is r of t, right? And our output, that is 1 minus e to the power minus t by capital T. So here, if you place small t, that is time, if it is equals to 0, then 1 minus e to the power 0, that is 1 minus 1, that is 0. So at time t is equals to 0, here we have 0 at output, and as time increases, you will be getting 1 minus something is decreasing, means your output that will increase exponentially. You can observe it will increase somewhat like this, right? It will increase somewhat like this. So this is our output, that is C of t, that is 1 minus e to the power minus t by capital T of u of t, right? That is our output. Now with this output, there are few basics that we need to know. Like you can observe here, output is increasing, but at what rate it is increasing? To identify that, we need to differentiate this C of t with respect to time. So rate of output means speed of output, right? So here rate of output is dct by dt, right? So if you differentiate this C of t, then you will be getting dct by dt, that is rate of output. Here 1 is constant, differentiation of that is 0, minus C e to the power minus t by capital T. So minus 1 by t, that will come front, and e to the power minus t by capital T, right? That will be as it is. So this is what rate of output. If you further simplify this, then you will be having dct by dt. See, minus minus, that is getting plus. So 1 by t into e to the power minus t by capital T. That is what rate of output. If you want to understand this rate of output over here in graph, then that is a slope at any instant, right? Like if I say we are talking about this instant, then slope that will be tangent to this curve, right? That slope will be rate of output, that is dct by dt, and that can be calculated by this equation, right? Now there are a few more basics that you need to understand, like how this output is increasing over here, right? So that one can understand by placing values in this equation. See, here I'll make a table first. So in table, here I will identify value of C of t with respect to time. So here I'll be considering t is equals to 0, t is equals to capital T, t is equals to 2t, t is equals to 3t, and t is equals to 4t, right? And here I'll substitute this in this equation. So at t is equals to 0, here 1 minus e to the power 0 means 1 minus 1, that will be 0. So output will be over here. Now we need to understand how output changes with respect to t, with respect to 2t, with respect to 3t, and 4t, right? So at this instant, what are the values that one can understand based on this equation? See, if you place t is equals to t, then 1 minus e to the power minus 1. If you calculate this, then you will be getting 0.63. 1 minus e to the power minus 1, that will be 0.63. So that is 0.63 over here, right? If you place t is equals to 2t in this equation, then 1 minus e to the power minus 2t by t means 1 minus e to the power minus 2. If you solve that in calculator, then you will be getting 0.86. So that is at this instant. If you place t is equals to 3t, then 1 minus e to the power minus 3 will be your answer. 1 minus e to the power minus 3, that will be 0.95, that is coming at this instant. And if you place t is equals to 4t in this equation, then 1 minus e to the power minus 4t by capital T, so that will be 1 minus e to the power minus 4. So that will be 0.98, right? So here we can identify the values. At 2t it is 0.86, at 3t it is 0.95, at 4t it is 0.98, right? That is how we can identify output. Now here you need to understand how this output is changing. It is changing with respect to parameter t. It is changing with respect to parameter t, right? So you need to understand what is t. See, if you have smaller value of t, then response will be faster, right? So if you have smaller value of t, then your response will be appearing somewhat like this, right? And if you have larger value of t, then your response will be slower, then your response will be appearing somewhat like this, you can observe, right? So here you need to understand this basic. See, if you have larger value of t, right, then your response will be slower like this. And if you have smaller value of t, then your response will be faster. So based on constant t in this transfer function, we can identify response speed, right? So here response speed, that is also based on parameter t over here, right? Still, if any confusion is there, then just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.